Okay, the first thing we want to talk about in 3.5, just factoring completely. Now, yesterday, this was a question, I didn't even realize it, but this was a question on, I think, the in-class version in here. Some of you may have gotten it. If you have to factor this problem, all right, first thing you should try and do is group, because there's 4 terms, right? If I group this, you guys agree with me that I can take out x squared in the first parenthesis. Okay, so if I take out x squared, I'm left with x minus 3. In the second parenthesis, it's already x minus 3. So what would I take out? I could take out a positive 1. Good. So when I take out that positive 1, I'm left with x minus 3. I know. Some of you got it. I was very pleased with. Some of you did not. So my new my new parenthesis is going to be x minus 3 out on top. That's my new GCF. And then whatever's left over gets its own parenthesis, x squared plus 1, right? This is set equal to 0. Now, we were talking yesterday and a couple days before that with real zeros, meaning x-intercepts where it crosses the x-axis, something you can graph. So in this case, this is a real 0 here, x equals 3. Over here, guys, when I have x squared plus 1 equals 0, I have to move this 1 to the other side, correct? So I have x squared equals negative 1. What happens when you take the square root of negative 1? It's imaginary. X equals here plus minus I. I had so many of you tell me that x equaled positive and negative 1. If it was minus, then you'd be all right. But if it's positive... I wasn't trying. I wasn't trying to be tricky. Hold on. Correct. So your answer on the test was just this one. Just, yeah, some people got it. It was just x equals 3. If I asked you for all of the solutions, it would have been x equals 3 and plus or minus I. But we asked you for just the real ones. That means just the 3. So be careful. You guys are going to see that from now on with the stuff we're doing in the next couple chapters. I gave some credit, but I can't give too much. All right, so now, guys, let's just talk very quickly. We've talked about this before, multiplicity. Multiplicity just means you have the same root, same answer, more than one time. So if it's written in factored form, you guys can tell me the multiplicity. X equals 0. If I solve that first parenthesis, x equals 1. How many times? 3, because it's the third power. The second one I have x equals negative 2. How many times? 2. Good. And x equals negative 3. How many times? 5. Let's remind ourselves, when I have an odd multiplicity like I do here, I have the same root 3 times and I have the same root 5 times. This function would go through the x-axis, right? If I have it an even number of times, what does it do at the x-axis? It doesn't go through. What does it do? It touches the x-axis and? Anybody remember? Anybody at home remember? We say it bounces or it touches and turns.
Oh, like, what, it goes through it twice or something like that?
No, it goes, here, I'll show you. Like if I had right here, x equals negative 2, and you got a multiplicity of 2, it would like touch there and go back down.
Oh, yeah.
Here, where you have x equals 1, it would go through. Whoops. We'll pretend that went through. So, just a reminder about that. That's just what we just talked about right there. This is just showing you guys, which I've been telling you all along, the highest, excuse me, the highest degree, the biggest exponent is how many zeros you have, how many solutions. They won't all be real. Some will be real, some will be imaginary. Some you might have more than one, something like that, but that's how many answers you should have. So if it's like to the 5th degree, look, x to the 5th power, you have 5 zeros. Some are real, some are imaginary, or they all could be imaginary, be real. All right, now this is not a difficult concept. This is just the opposite of what you guys have been doing pretty much your whole lives, right? Generally, I give you a long equation and I say factor it. Tell me what x equals. Tell me the zeros. Now we're going to do something where I'm going to give you the zeros and you're going to tell me what the original equation was. Okay, so like, look at this question. The first one says zeros of. Okay, so I'm going to write out x equals positive I, x equals negative I, x equals positive 2, and x equals negative 2. Okay, everybody understand that? They told me the zeros were right here, so I just wrote out x equals all this time. So we talked about linear products. Excuse me, we talked about linear products last few days. How would I write these answers in as linear products? What would my parentheses look like? When I move that over, what does it become? Good, x minus I. This one becomes what? Good, x plus I. This 2 becomes x minus 2, and this 2 becomes plus 2. And all of this equals 0. Now we're going backwards. You have a question? Okay. So let's FOIL. Right? We don't do everything at one time. Let's just do the first 2 together. What is x times x? Perfect. What is x times I? Just stick them together. xi, ix, however you want to write it, doesn't matter. What happens with negative I and x? Negative xi or ix, whatever. And then what's negative I times positive I? Negative I squared, guys. Every time we see negative I squared, what do? We cross it off. Good. We change the sign and we make it a 1. Perfect. So combine like terms. What happens with a positive xi and a negative xi? They cancel out. So I'm left with x squared plus 1. Everybody see that? No, not yet. We got to do this other 2 here. It's just a long, this is not a very like difficult concept to understand. It's just a pain. You got to be careful. You really easily make tiny little mistake and then your whole problem is messed up if you miss a sign or something. So over here, we're going to go x times x is x squared. X times 2 is 2x, right? Negative 2 and x is negative 2x. Hey, Mr. Yurko. And negative 2 positive 2 is minus 4. So I'm left with x squared. What happens to my 2's? They cancel, and then I have minus 4. All right? Now what do you think we do? FOIL again. Okay, so x squared and x squared is x to the 4th. X squared times negative 4 is negative 4x squared. 1 times x squared is plus x squared. And 1 times negative 4 is minus 4. And then simplify. So this ends up being x to the 4th minus 3x squared minus 4 equals 0. And that would be your final answer. So I'm going to give you zeros. I'm going to give you the x equals, and you guys are going to work backwards and figure out what the original equation would look like. When you guys have i's, whenever you're given a 0 and it has an I in it, every single time you work backwards and multiply everything together, do I have any i's in my answer? No, your i's will always cancel out. So if they don't, then that's a hint. We're like, uh-oh, I did something wrong. Okay? The second one, I'm not going to work it out, but it tells you degree of 4. That means your polynomial should start with x to the what? 4th, okay? It tells you that their zeros are negative 2 and 0. What else did they tell you? What else did they tell you about negative 2? It has a multiplicity of 3. Well, what does that mean? Okay, so if we have a multiplicity of 3, what does that mean? What else? What do I need to write?
You need to write it 3 times, like x plus 2.
I have to write it 3 times. Now, do I have my 4 answers?
Yeah.
Yep. So we would write out x plus 2, right? X plus 2. Because they tell you that the zeros are negative 2 and 0. And then it tells you that there's a negative 2 has a multiplicity of 3. That means, oh, I have negative 2 3 times. Yeah. Okay, next one. Whenever a plus bi is 0, its complex conjugate is a minus bi is also 0. Okay, remember that. You guys got that? So anybody? We talked about imaginary numbers. You talked about these in Algebra 2 for sure. Does anyone remember just hearing about complex conjugates? Crickets. Okay. So then nobody remembers what a complex conjugate is. Okay. Think about when you see complex conjugates, right? I want you to think of opposite. If I said to you 3 plus 2i, and I said, what is the complex conjugate of 3 plus 2i? And you guys are like, oh. Perfect. 3 minus 2i. Perfect. If I said to you, what is the complex conjugate of negative 4 minus 5i? Negative 4 plus 5i. Very good. The only thing that changes is the sign in between the real number and the imaginary number. Imaginary part, I should say. What about if I said, what's the complex conjugate of 6i? It's positive 6i, right? So what's the complex conjugate? Negative 6i, all right? Now, the reason that this is super important is because you're going to be given zeros, like I told you. They're going to say, given x equals, let's just say, x equals 3, x equals 2, and x equals 4 plus I. They're actually telling you that there's 4 roots to this problem. How many do you see? How many x's did I give you? 3. But I'm telling you right now, there's 4. Every time you're given an imaginary root, imaginary answer, imaginary x, you automatically have to account for the conjugate. So if I see 4 plus I also have to know I need to write what? 4 minus I. Every time you have an imaginary root, you have to account for the conjugate. You have to write down the opposite one. They're not going to give it to you, but you have to know to do that. You don't do that with the real ones. You don't just be like, oh, I'm going to make up a new one, and it's going to be up negative 2 as well. It's only with the imaginary ones, okay? Okay, we'll do that more on Monday. Okay, let's do this problem, and then we'll talk about what Monday and Tuesday are going to look like. You had one of these that factored out nice and pretty on your all's version of your test. Anybody remember it? It was x to the 4th. Whoa. X to the 4th. Some of you. X to the 4th, and then I think it was minus 18x squared plus 81. Okay. Now, about 90% of you that got this right did the No, can't do quadratic because it's not squared, but you did the P over Q. You listed out the factors of 81, and you did the synthetic division. It was great. And it was wonderful because you were like 1, and then there's no x cubed, and then it's negative 18, and then there's no x, and then it's 81. I was really, really impressed with that. There was a couple of you that were like, oh, that factors. What times what gives you x to the 4th? Yes. X squared. Right? What times what gives you a positive 81 when you multiply, but a negative 18 when you add it? Minus 9. Minus 9.
So that was the right thing to do?
No, it doesn't matter. Either way. And then can you factor that more? X plus 3, x minus 3, x plus 3, and x minus 3.
Well, how did you put x plus 3 squared?
That's fine. That's fine. You can write x plus 3 quantity squared, x minus 3 quantity squared. That's fine. But either way, you would have gotten the same answer. If you see that something factors, guys, factor it. The only time we really have to use P over Q is when it doesn't factor. So in this case, this factors. What times what gives you x to the 4th? x squared, and x squared. What times what gives you negative 8 when you multiply, but a positive 2 when you add? Negative, what? Okay, minus 2 plus 4. Everybody agree? Okay. Now, you're going to have 2 answers here. Or you're going to have 4 answers. When I set this equal to 0, when I say x squared plus 4 equals 0, I'm going to have 2 answers. And when I say x squared minus 2, I'm going to have 2 answers. 2 of them are going to be real, and 2 of them are going to be what? Imaginary. Don't make the mistake of, oh, it's going to be plus minus 2 on the left-hand side. Because when you move the 4 over, guys, what does it become? Negative 4. When I take the square root of a negative number, what does it become? Imaginary. So this is x equals plus or minus 2i. And then over here, when I move the 2 over, x equals 2, x squared equals 2. Take the square root, and I get x equals plus or minus square root of 2. All right, we could graph this if we needed to. The square root of 2 is between 1 and 2 on your x-axis. Can I, do I graph positive and negative 2i on a regular graph? No. So here you do have 4 solutions. We started out at the beginning with 4 solutions. But you guys have to understand that 2 of them are imaginary. So you could write this as x plus 2i, x minus 2i, and this would be x plus root 2, and x minus root 2. And believe it or not, when you FOILed those, all 4 of those, you multiplied them together, you would come back to this. Every time you are given roots and you go back to a polynomial, it's going to look like a normal polynomial that you guys have seen before. Your answers may not. Right? You wouldn't think that if you multiplied all 4 of those together that you would have gotten something that looked very decent like x to the 4th plus 2x squared minus 8. So just be mindful of that.